A vast stillness hangs in the void between galaxies. Here, in the dark cathedral of the cosmos, stars burn like ancient watchfires, holding their vigil over an ocean of nothing. Yet something stirs. It does not blaze. It does not sing. It moves. Like an absence, a hollowing out of what should be. At the threshold of perception, the universe trembles. Time itself, that invisible loom upon which all existence is woven, seems to falter. Subtle ripples coil through the sequence of cause and effect, as if the arrow of time has bent beneath an unseen weight. Moments stagger and blur. Like cracks spidering silently across a frozen lake, they spread. Unseen yet irreversible instruments. Whisper of impossible dissonances. Pulses from distant pulsars arrive a heartbeat early. Entangled particles flicker out of sync, vanishing a breath before they appear. It is not chaos, but something older than order. An ancient fracture. Opening soundlessly within the machinery of reality. No one hears this rift, yet it devours certainty. It is not an explosion, nor a void. It is a wound without sound, carved through the fabric of time. And still, the universe continues its silent expansion, as if unaware of the fault line spreading beneath its own foundations. The question grows. Darker, heavier, almost unbearable, is time, the constant that carries every heartbeat, every orbit, every memory, beginning to break? Or has it always been broken? And only now are we beginning to glimpse the fragile seams of the illusion that once held everything together? The silent rift tearing through the fabric of time did not begin with a flash of revelation. It began with a hesitation. A pause so slight it could have been mistaken for nothing at all. Far from the warmth of stars, on the cold screens of deep space observatories, the first signs emerged as whispers in the data, stray pulses arriving a fraction of a second too soon or too late. They appeared within the long, patient watch of the European Space Agency's Gaia Observatory, which has spent years charting the positions of over 1 billion stars. Among its torrents of starlight measurements, hidden like fractures in glass, came irregularities in the timing of distant pulsars, cosmic clocks whose precision had been trusted like scripture. The pulses had always arrived like heartbeat and breath, steady across centuries. Until they didn't. At first, the discrepancies were blamed on cosmic dust or magnetic storms bending the signals. But when the anomalies reappeared months later, cleaner, sharper, undeniable, they ignited a quiet unease. Something was shifting, not in the stars themselves, but in the very sequence that carried their light to us. The clues multiplied. On the other side of the continent, deep beneath the French-Swiss border, physicists at CERN were colliding particles at near light speeds. In the roar of the Large Hadron Collider, a different kind of dissonance appeared. Entangled particles that should have spun in perfect symmetry instead arrived out of phase, as though one had received a message from the future and the other had not. It was a tiny discrepancy, measured in trillionths of a second, but physics is built on symmetries. Even the faintest fracture can unmake the whole. Among those who first whispered of deeper causes was Kip Thorne, who had long speculated on the chaotic churn of spacetime at the Planck scale, the so-called quantum foam, where spacetime might flicker between being and nothing. In his lectures, he spoke of the possibility that microscopic warps in temporal order could momentarily bloom there, too brief to see, yet real enough to ripple outward, and echoing like a ghost from the past. The words of Stephen Hawking resurfaced. His warnings about closed time-like curves hidden in general relativity, loops in spacetime where cause and effect might exchange places. Hawking had proposed a chronology protection conjecture, a hypothetical law preventing paradoxes from ever forming. But if these ripples were real, that protection may be failing. At first, the scientific community resisted the thought. There had to be a simpler explanation. The researchers who stumbled upon these clues had not been searching for temporal fractures at all. They were hunting something else entirely, the elusive particles of dark matter, the invisible scaffolding, thought to hold galaxies together. To find it, teams sifted through colossal archives of cosmic background noise. Yet buried within the static, they uncovered temporal dissonances, pulses that slipped out of sync, like the ghost of a heartbeat skipping dot, and so the picture grew stranger. Disparate instruments, separated by oceans, began reporting the same. Impossible note. In Chile's Atacama Desert, where the Atacama Large Millimeter Array gazes through the dry air at cold molecular clouds, astronomers logged radio flares that seemed to curve backward through time, faint echoes preceding their own sources. Thousands of kilometers away, atomic clocks and Earth-orbiting satellites, the backbone of global positioning system. Navigation recorded picosecond drifts that did not match known relativistic effects from velocity or gravity, piece by piece. The clues aligned, and what they hinted at was not an error, but an intrusion, a phenomenon not rooted in space, but in the order of time itself. Some spoke of data corruption, of flawed software or calibration drift. Others pointed to gravitational waves, fleeting ripples from merging black holes, though their timing patterns did not fit. The data was too clean, too deliberate. As these scattered threads converged, they drew an outline of something immense, yet unseen, like the shadow of an invisible continent beneath the ocean of spacetime. A pattern, faint but coherent, threading through different laboratories, instruments, and wavelengths, from radio to gamma, from protons to pulsars. The realization crept in slowly, like frost across glass. Perhaps the rift had been there all along, slumbering beneath the reach of our instruments. And only now, with humanity's gaze sharpened by decades of progress, were we able to glimpse its edge. This was not the triumphant unveiling of a new planet or a distant galaxy. There was no image to admire, no celebration to announce. There was only silence, and the growing certainty that something had begun to unravel inside the hidden machinery of time. In the beginning, disbelief was almost universal. The human mind has always leaned on time as its most faithful pillar, silent, constant, beyond question. Every law of physics rests upon its steady march. Every experiment assumes its flow. But now, the data seemed to whisper something sacrilegious. Time was not keeping its own promises, for generations. Science had treated time as a continuous dimension, a smooth axis stretching from past to future. General relativity described it as pliant, bending with gravity yet never tearing. And within the microscopic realm, quantum mechanics danced with uncertainty, but always forward, always obeying causality. The arrow of time had been sacred, yet the signals spoke otherwise. Particles were arriving out of order. Pulses from ancient stars stumbled as if tripped. And even stranger, in rare cases events seemed to anticipate themselves, shifting into position a breath before their causes could occur. This was not just an anomaly. It was heresy. Because if causality falters, all of physics trembles. Without cause preceding effect, the universe becomes incoherent. Equations dissolve. Experiments lose meaning. Reality becomes a hall of mirrors, where consequence can precede choice and the future might sculpt the past. It was here that the first real fear emerged. Not fear of disaster, but of collapse, the collapse of comprehension itself. The community splintered. Some dismissed the rift as nothing more than noise, a statistical mirage conjured by overly sensitive instruments. Others warned of confirmation bias, of seeing patterns where none existed. A few even accused the observers of tampering. Desperate to protect the sanctity of physics from the combination of paradox, yet denial could not hold. The signals returned again and again, each time cleaner, sharper, refusing to be erased. At the Max Planck Institute for Gravitational Physics in Germany, ultra-precise optical lattice clocks began to drift from each other in ways that could not be explained by gravitational gradients or thermal fluctuations. In the data streams from LIGO and Virgo, faint after-echoes followed certain gravitational wave detections, as if the spacetime fabric itself had shuddered twice, once on time and once before. Each clue was like a whisper from the void. Unsettling not because it was loud, but because it was consistent. This was where the weight of history pressed in. A century ago, Albert Einstein had cracked the firmament of classical physics with his vision of curved spacetime. A few decades later, Niels Bohr and Werner Heisenberg shattered certainty again with quantum indeterminacy. These revolutions had been shocking, but they had not unmade causality. Even in uncertainty, time had still flowed forward. This was different. This was not a new planet in the same cosmos. This was a crack in the cosmos itself, some theorists whispered of. Closed time-like curves, loops permitted by Einstein's equations under extreme conditions, such as near-spinning black holes. Stephen Hawking had once argued that the universe must forbid such loops through a chronology protection principle or risk dissolving into paradox. But now, the rift seemed to mock that protection. If closed loops were forming, even fleetingly, then the universe was allowing causality to fold back upon itself. The implications were vertiginous. Imagine a universe where actions do not merely lead to consequences, but consequences can leak backwards, subtly sculpting their causes. A reality where the future is not waiting to be born, but quietly editing the past, even as it arrives. It would explain the anomalies. It would also annihilate everything physics assumes. The deeper the scientists looked, the more unsettling the patterns became. The rift did not behave like a local disturbance, not like a gravitational well or a magnetic storm. It had no fixed coordinates. It surfaced wherever time was measured precisely enough. It seemed to drift, like a shadow cast by something that existed outside the flow entirely, and that was perhaps the most disquieting truth. It obeyed known law. Every force in the universe, from electromagnetism to strong nuclear force, can be described by equations that predict their behavior. This did not. It resisted prediction. It seemed untethered. A creeping unease settled over conferences and private discussions. If the laws of physics are the grammar of the cosmos, then time is their syntax, the structure that makes meaning possible. Without it, the universe becomes not just chaotic, but mute. And so the fear deepened. Not of catastrophe, but of silence, a silence where no explanation can live. This was the scientific shock, that the bedrock beneath every thought, every equation, might not be bedrock at all, but ice cracking quietly in the dark, before there were stars, before galaxies traced their luminous spirals across the void. There was only the silent, seething potential of everything yet to come to approach the question of what existed before time. We must tread carefully, for the word before itself is tangled in the very fabric of time. If time did not yet exist, can anything meaningfully be said to have occurred prior to it? This paradox forces us to stretch beyond ordinary logic and peer into the strange frontiers of cosmic inflation and quantum cosmology, where beginnings blur into something far more elusive. Some cosmologists propose that our universe sprang from a timeless realm, a quantum vacuum. This vacuum is not nothing in the everyday sense. Rather, it is a frothing sea of energy fluctuations where particles and antiparticles wink in and out of existence. In this view, time as we know it did not exist in the vacuum. Instead, the sudden burst of cosmic inflation sparked not just the expansion of space, but the very arrow of time itself. Before this, asking what happened is like asking what is north of the North Pole. The question collapses under its own meaning. Yet another radical idea imagines that time might be an emergent property. In this framework, the fundamental ingredients of reality are timeless quantum states, abstract mathematical structures described by the Wheeler-DeWitt equation, which notably contains no time variable at all. According to this picture, what we perceive as time may simply emerge when these states entangle and evolve in complex ways. Time, then, is not a background stage on which the cosmos plays out. It is a mirage rising from the play itself. There are also whispers of something even stranger, the notion that time could be cyclic. Some versions of the Big Bounce model suggest that our universe might have collapsed in a previous cycle, compressing everything into a dense state before rebounding into the expansion we see today. If so, what we call the Big Bang might be just one heartbeat in an eternal cosmic rhythm with no absolute beginning at all. In this endless loop, there is no first moment, only an eternal recurrence of birth and death, expansion and collapse, like a cosmic tide with neither origin nor end. Such possibilities push the human mind to its limits. They force us to accept that our familiar experience of past, present, and future may be only a local illusion born from conditions that did not always exist. If time itself had to be created, then the true beginning of our universe is not just a moment in time, it is the birth of time. To glimpse what came before, we may need to let go of time entirely, and step into a realm where before and after have no meaning at all. Echoes from the first light. Once the newborn universe burst forth from its timeless slumber, it was a place of unimaginable heat and density, a roiling ocean of energy where particles and forces danced in chaotic unison. In these first fleeting instants, the cosmos was more like pure light than matter. It glowed with a brilliance beyond comprehension, yet this light could not travel freely. The universe was too dense, too hot, too wild for photons to escape. Space itself churned like a storm, shaped by forces just beginning to separate from one another. As the universe expanded, it cooled, and this cooling triggered a cascade of cosmic milestones. Around 1 second after the Big Bang, the fundamental forces of nature, gravity, electromagnetism, and the nuclear forces began to take on their distinct roles. Protons and neutrons formed, fusing into the first atomic nuclei through a process called Big Bang nucleosynthesis. The infant universe was still opaque, but its structure was being written in invisible strokes, laying the groundwork for all future matter. Hundreds of thousands of years later, a profound transformation occurred. The cosmic microwave background, CMB, was born. As the universe cooled to about 3000 Kelvin, electrons finally combined with nuclei to form neutral atoms, a moment called recombination. For the first time, light could travel freely through space. This ancient glow still surrounds us today, stretched and cooled by the expansion of the universe until it now whispers across the sky as faint microwaves. The CMB is the oldest light we can see, a ghostly echo from when the universe was just 380,000 years old, carrying secrets from the dawn of time. These relic photons are not evenly spread. They hold tiny ripples-minute fluctuations in temperature and density. Those ripples, mapped in exquisite detail by missions like COBE, WMAP, and Planck, are the fingerprints of the primordial universe. From them grew the vast cosmic web of galaxies, stars, and planets that now fills the heavens. They are the seeds from which all cosmic structure blossomed. To study this ancient light is to peer across almost the entire history of existence. Every flicker carries the imprint of the universe's first heartbeat, encoded in patterns so faint they nearly vanish into the background. And yet, from these fragile whispers, we can reconstruct the story of how the cosmos awoke. They are the universe's oldest memory, a shimmering afterglow from the moment when darkness gave way to light, and the first chapters of space and time were finally written. The fractured clockwork for billions of years, the universe has appeared to flow with serene inevitability. Stars ignite, blaze, and collapse. Galaxies drift apart on the tides of expansion. Planets trace their orbits with unwavering grace. It is a grand celestial clockwork, each gear turning within the steady rhythm of time. Yet beneath this apparent order, subtle fractures are emerging, hairline cracks in the foundation of temporal reality itself. The smallest scales, where the smooth fabric of spacetime dissolves into the foaming uncertainty of the quantum realm. Time no longer behaves as a continuous flow. In these shadowed depths, particles flicker in and out of existence, borrowing slivers of energy from the void, then vanishing before the universe can even record their presence. According to quantum mechanics, the sequence of cause and effect becomes blurred. The arrow of time wavers, momentarily directionless, like a compass needle in a magnetic storm. Even on cosmic scales, this certainty begins to erode. Observations of distant supernova reveal that the universe's expansion is accelerating, driven by an unseen pressure known as dark energy. This force stretches space itself, subtly distorting the way clocks tick and distances unfold. Time does not move uniformly through the cosmos. It dilates near massive bodies, slows within intense gravitational wells, and stretches thin across the silent void between galaxies as described by general relativity. To observers scattered across this vast expanse, the universe does not share a single universal present. Each vantage point carries its own private version of now. This shattering of a unified timeline has profound consequences. It suggests that past, present, and future are not absolute, but woven together in a four-dimensional tapestry called space, and if time is part of this fabric, then it is not immune to tearing. At the heart of black holes, where gravity becomes infinite and spacetime curves into a singularity, our known laws of physics collapse. Here, time does not simply slow, it ceases to have meaning. The equations dissolve into paradox, hinting that beyond these boundaries, time itself may fracture or fall back upon itself. Some theoretical models of quantum gravity suggest that the very continuity of time might be an illusion, an emergent property rising from deeper, timeless structures. If true, the cracks we see are not signs of time breaking, but glimpses of what lies beneath it, a realm where moments do not flow, but simply exist all at once, like pages of a book already written. Such possibilities haunt the edges of our understanding. The cosmic clock still ticks, yet its gears are grinding against something unseen, something that may not obey the logic of before and after. And so, as the stars wheel in their patient arcs, a quiet question grows louder. If the foundations of time can splinter, how long before the whole clockwork comes undone? Echoes beyond the horizon. If time can fracture, what then becomes of us who are made of moments? For centuries, humanity has imagined time as a river flowing forward, bearing every life from birth to death and every civilization from dawn to dusk. Yet the silent rift that trembles through the fabric of spacetime threatens to erode even that ancient metaphor. If the sequence of moments can unravel, then our lives, our histories, our futures may not be journeys at all, but scattered fragments adrift in a timeless ocean. Physicists now peer into this abyss with instruments of exquisite sensitivity, seeking traces of the impossible. The European Space Agency's LISA mission will listen for whispers of warped spacetime, catching the faint tremors of colliding black holes as they ripple through the void. At the CERN Large Hadron Collider, protons are shattered at near light speeds, revealing the subatomic chaos where quantum mechanics and general relativity clash like opposing tides. Meanwhile, cosmic observatories such as James Webb Space Telescope stare into the ancient dark, seeking patterns in the first light that might betray how time itself was born. Each measurement is an act of defiance, an attempt to chart a coastline on a sea that may have no shore. Yet the closer we draw to the rift, the less the universe resembles a clockwork, and the more it resembles a vast frozen field of possibilities. All moments coexisting, awaiting the gaze of consciousness to make them real. This idea, called block universe, suggests that past, present, and future are not flowing but fixed. The arrow of time may be only an illusion born from entropy, the slow spreading of order into chaos. If entropy someday reaches its ultimate climax, the heat death of the universe, the arrow may fade entirely. Time would stop not with an explosion but with stillness. Others envision more violent fates. Some propose that the accelerating expansion driven by dark energy may tear apart galaxies, stars, even atoms, a hypothetical end called the Big Rip. In such a cataclysm, spacetime itself would disintegrate and time, losing its stage, would have nowhere left to unfold. And yet, there is wonder in this terror. If time can fracture, perhaps it can also be reborn. Theories of cosmic inflation and quantum fluctuations hint that new universes may bloom from the void like sparks, each with its own timeline, its own rhythm, its own fragile stream of moments. Our universe may be just one heartbeat in an eternal, silent pulse. In the end, the rift tearing through the fabric of time is not only a scientific enigma, it is a mirror. It forces us to confront the fragility of every heartbeat, every thought, every fleeting second we call the present. If time is breaking, then everything we are is carved upon a crumbling shore, and if time has always been fractured, then perhaps we are not moving through it at all. Perhaps we are simply awakening for a moment in one of its endless, scattered shards before sinking back into the silence beyond the horizon.